Hi learners! On this video lesson, you will learn to develop precise definitions of rays and line segments from the basic concepts in geometry, namely points and lines. You will also learn the differences and similarities between lines, rays, and line segments. These ideas will be presented visually in detail to let you understand the concepts easily. Real-life representations are shown to make the concepts relatable and meaningful. Strategies in analyzing and answering sample problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on lines, rays, and line segments, or if you have an assignment on these topics, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. On the previous video lesson, the three fundamental concepts in geometry, which are points, lines, and planes, were described. The link of the video is down below. While these three are just described, not defined, for there are no simpler concepts that would define them, they served as the basis for defining other geometric terms. On this video lesson, we're going to use these concepts in defining rays and line segments. Recall that a point is described as a location and is visually represented by a dot and named by using an uppercase letter of the English alphabet. It has no dimension. On the other hand, a line is described as a series of points connected to each other that goes infinitely on both directions. It is named by using two uppercase letters of the alphabet, representing 2 points on the line with the symbol of the line on top the letters to show that the line goes infinitely on both directions. Recall too that the order of the letters on its name doesn't matter. So line AB is the same as line BA. Another thing that we need to remember is that a line can also be named using the lowercase letter of the alphabet. So the same line can also be named as line N. Another fact about lines is that it has one dimension, length. Now look at these learners. What did you just see? You're right, a part of the line disappeared, leaving just a part of it. This part of the line has a special name. This is called a ray. A ray is a set of points on a line that has one terminating end and the other end is extending infinitely. Let us label 2 points on the ray so that we can formally name the ray. We will particularly label the endpoint and another point on the ray. With 2 points labeled, we can now name the ray by having the endpoint first, followed by the other point with the symbol of the ray on top that is directed to the right away from the endpoint. Remember these learners, the order of the letters is important here. The name always starts with the endpoint. Just like a line, a ray has one dimension, length. Look at these learners. What do you see here? You're correct. We have here rays intersecting each other. Where do the rays intersect? The ray intersect at a point. Here, the point of intersection of the two rays is point E. Just like lines, rays intersect at a point. Now look at these learners. What did you observe, learners? You are correct. The line is split into 2 opposite rays. So when a line is split, it forms 2 opposite rays. It then follows that 2 opposite rays form a line. Do you agree? Real-world examples of rays include rays coming from a flashlight, rays from a lighted candle, rays from fireworks display, and rays from the sun. Now, can we measure the length of a ray? Though there is an end point on a ray, the other end is extending infinitely, so we cannot measure its length, just like a line. Let us now move to the next. What just happened, learners? You're correct. The line is reduced to a segment. We call this a line segment. Note that it has endpoints. Let us identify the endpoints by naming them so we can name the line segment. As you see, a line segment is a part of a line bounded by two endpoints and contains every point on the line that is between its endpoints. With the endpoints named, we can now name the line segment. So the name of the line segment is segment BD. The symbol on top is the symbol for the line segment. It indicates that the line segment has terminating points. In this case, the terminating points of the line segment are points B and D. Just like a line, you can interchange the letters representing the points. So you can also name it as segment DB. Remember this, learners, you can't do this to a ray. The name of the ray always starts with its endpoint. Now look at these, learners. Where do the line segments intersect? There you are. The line segments intersect at a point, just like lines and rays. We have lots of real-life representations of line segments. Pencils and pens, chopsticks, metals on bridges, woods on fences, structures used as safety nets in construction sites, and frameworks of structures are all line segment representations. Can you measure a line segment? Yes, of course, because line segments have endpoints. You can measure the length of this chopstick, right? So far, we have noticed the following differences between lines, rays, and line segments. First, the representation differs. For a line, we have this, indicating that a line extends infinitely on both directions. A ray has this, indicating that it extends infinitely on one direction. And finally, a line segment has this, signifying that it has endpoints. Second, their measurability differs. While line segments are measurable, lines and rays are not. Third, the way how they are named differs. For lines and line segments, the order of the letters doesn't matter. But for rays, the end point comes first. The names also carry with it different symbols. The following are some similarities that we have observed. First, they have the same basic elements, points. Second, they are named using 2 points. Third, they intersect each other at a point. Fourth, they all have one dimension, length. Okay, let us now answer the sample problems that follow. Here is the problem. Use the figure below to answer its question that follow. Question A, name 2 opposite rays on line M. Question B, name 2 line segments. Question C, name the lines that intersect at point A. Question D, name the intersection of line N and line AB. Question E, name 2 rays intersecting at point E. As usual, we begin by reading the problem to know what we're looking for and examine what are given to figure out how the given information help find what we're looking for. Here, we're asked to answer several questions and we're given a diagram. The diagram consists of intersecting lines. This is how we will answer the problem. We will deal with the questions one by one or one after the other. Determine what the question is about. Identify the key concepts that relate to the question and apply the concept in determining the answer or answers with the use of the diagram. Let us start with question A. Here, we're to name two opposite rays on line M. Remember that a line can be split to form two rays. Furthermore, we know that a ray is a set of points on a line that has one terminating end and the other end is extending infinitely. So, we will look for line M on our diagram first and then determine opposite rays that are on the line. Let's go. Here are the rays, ray DE and ray DC. We will move on to question B. Here, we're to name two line segments. Remember that a line segment is a part of a line bounded by two endpoints and contains every point on the line that is between its endpoints. We have lots of those here. Okay, so here is one, segment CA, and another one, segment BF. We will now move on to question C. We are to name the lines that intersect at point A. So, we will look for point A on our diagram, then trace all the lines that intersect at point A. Let's go. Okay, so the lines are line T, line L, and line AC. We will now move on to question D. We're to name the intersection of line N and line AB. We will look for line N and line AB on our diagram, then find out where they intersect. There you are, the lines intersect at point B. Next, we will move on to question E. Here, we're to name two rays intersecting at point E. We will start by looking for point E. Then, identify the rays intersecting at point E. Let's go. Here are the rays, ray EC and ray BF. Other than these two, you can name other rays intersecting at point E. There you are, learners. Those were all easy questions. Let us now move on to sample problem 2. Here's the problem. The map below shows a portion of some roads in a city. Use the map to answer the questions that follow. Question 1. Which option best represents T Avenue? Option A, ray. Option B, line. Option C, point. Option D, line segment. Question 2. Which option best represents 12th Street? Option A, ray. Option B, line. Option C, point. Option D, line segment. Finally, question 3. Which option best represents C Street? Option A, ray. Option B, line. Option C, point. Option D, line segment. As usual, we begin by reading the problem to know what we're looking for and examine what are given to figure out how the given information help find what we're looking for. Here, we're asked to answer several questions and we're given a map. The map consists of intersecting lines representing roads. Just like what we did in sample problem 1, we will deal with the questions one by one. Determine what each question is about, identify the key concepts that relate to the question, and apply the concept in determining the answer with the use of the map. Let us start with the first question. Here, we're asked which option best represents T Avenue. Let us go to our map and look for T Avenue. Okay, now, which of the options best represents T Avenue? Is it option A, option B, option C, or option D? Okay, so the answer is option A. Array is the best representation for T Avenue. We now move on to question 2. Here, we're asked which option best represents 12th Street. We will look for 12 streets on our map. Here it is. Which of the options best represents 12th Street? Is it option A, option B, option C, or option D? Okay, so the answer is option D. A line segment best represents 12th Street. We now move on to question 3. Here, we're asked which option best represents C Street. We will look for C Street on our map. Okay, so here it is. Now, which of the options best represents C Street? Is it option A, option B, option C, or option D? Okay, so the answer is option B. A line best represents C Street. There you are, learners. The questions were again easy. I hope that you have acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, a point is described as a location and is visually represented by a dot. Second, a line is described as a series of points connected to each other that goes infinitely on both directions. Third, array is a set of points on a line that has one terminating end and the other end is extending infinitely. Fourth, a line segment is a part of a line bounded by two endpoints and contains every point on the line that is between its endpoints. Fifth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what you're looking for. Sixth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.